Okay, so another really important factor to consider when you're looking at graphs and you're describing graphs is again the idea that the actual visual representation of a graph can be quite tedious to draw, and sometimes you just kind of want the outline, the bare basics, like the same kind of thing that when you walk into a room and you see, oh, there's 5 people, you don't necessarily want or care about all the little details involving like where they're sitting, what they're doing and all that kind of stuff. So this is, the descriptors to help give you a broad idea about the graph itself. Kind of again, like if you're walking in and you saw a group of people, you just went like, okay, it's approximately 20 people. They are all first years or they are all post grads. That would be enough to, get you going in acclimatizing yourself to what's happening, basically. So we're going to start off with the definition of an order. And the order of a graph is basically just the number of vertices in the graph. So one of the things that we're going to just discuss here is the fact that I use the bars here for the vertices, like that. So in set theory, when you do have those, you usually know them as absolute value kind of bars. It is indicating what this is saying, that the absolute value bars with the vertices set inside of it is telling you that it's looking at the number of elements in that set. So it's the number of vertices of the graph that it is looking at. So if we go to the example, the number of vertices for this graph over here, we have 1, 2, 3, 4. So the order of this graph is equal to 4. It's the number of vertices. So let's just also just do this. U, V, W, Z. And we can write this as the number of elements in the vertices set. V is equal to 4. Okay, so let's just do that one more time just so you can get comfortable and familiar with the notation. We're going to first write down the vertices set. So we have the vertices set of the graph G, let's just call this one graph G, is equal to, and you're going to have U, V, W, and Z. Then we're going to say the number of elements of the vertices set of the graph G is equal to, and then we just count the number of elements, 4. That also means that the order of graph G is equal to 4. Right, now the size of the graph is the number of edges. So the size is your number of relationships. That kind of makes sense because again, you're looking at a system, you're investigating, the links between the different objects, you're looking at those patterns of the relationships. So the size would be the number of relationships that there are. So the size of the graph is the number of edges of that graph. So in this case, the size would be 1, 2, 3. The size of G is equal to 3. Now you can also pause this and actually go and label the graph, label the edges of the graph, and then write out everything again. But just be aware, the number of elements in the or in this case it's just a set of the edges of G is equal to 3 because there are 3 edges. Okay, let's do it for the bottom one, which we're just going to label H. So our graphs don't have to always be called G. We can label them whatever we want. So that's graph H. And we're going to be, okay, what's the vertices set? The vertices set in this case is U and V. Let's do the edge set, just, practice it a bit. So you're going to have UV and you're going to have UU. Okay, so now we have the number of elements in the vertices set is equal to 2, and the number of elements in the edge set is equal to 2. And again, so now the order of the graph is 2. Ooh, big mistake I made there. I labeled the graph G, H, and I kept writing G because I was just so used to writing G. I should just be aware of that and be consistent.